Now, once we know why we need threads, let's try to create multiple threads here. And of course, to create multiple threads, it's not like just because we have a concept of threads we are going to use in every application. What if I say most of the time you don't even create threads by yourself? See, when you build applications, we use certain frameworks, right? Now, behind the scene, these frameworks will create threads for you. So if you work on a big project, there's a high chance that you will not even write threads by yourself. But then it's always better to get hands-on on some underlying concepts, right? So let's do it here. So what I will do is, let's go for an imaginary concept here. Let's say I have a class hi whose job is to print hi, okay? Or maybe I will just say a class A whose job is to print hi. So what I will do is I will try to create a function here, public void show. And in this show, I want to print hi, nothing fancy, just hi here. The only thing is I want to print this hi multiple times. So I will simply use a loop here. I can say int I equal to 1 and I less than equal to 10 and I plus plus. Okay, and then we are putting this inside a loop. So of course, when I call this particular function, which is show, of course, it will execute hi 10 times, right? Now let's say I just copy this code and I paste it here. Now what I'm trying to do is we have two classes with the same concept almost, because they both have the same method name, which is show. They are both running a loop for 10 times. The only thing is the second loop actually prints hello. The first function here prints hi. The second one prints hello. That's the only difference. And of course the class name is different. And now I will go back to my main method, and here I want to create object of these two classes. So we got A class, we got B class. Let's create object for them. So I will say A obj1 is equal to new A. So we got the object for A. And then I can say A obj2 is equal to new B. And we got the object for B. Okay, simple stuff. And now I want to call those methods. Of course, I can simply say obj.1.show and obj2.show. So basically what I'm doing is I got object of both the classes and I'm calling the show method. And I'm thinking it should work, and why not? Why it will not work? We have done so many Java codes till now, everything was working. Let's see what happens. So I will compile this code, and you can see there's no problem. There's no compile time issue. And if I run this code, oh, okay, we got the output, right? So we got all highs here, and we got all hellos, right? Now that's how your system basically works. You know, your execution will start from main. Main will say, okay, when your JVM is executing the Java code, it will start the execution from main. And from main, it says, okay, this is the first line which I want to execute. The first line is simply create the object. Now, behind the scene in the heap memory, you will get this object, okay? Now, the second line says, okay, create the B object. It will say, okay, B object done. And since everything goes in sequence, it will complete this task, these two tasks. Then it will go for the next statement, which is calling the show method of A class, right? So it will say, okay, now I have to actually move. So if you try to imagine a pointer here, not the pointer in different languages, I'm saying just saying the which statement is getting executed. Okay, where is your executor here? So the executor says, okay, my job is to execute this show method, right? So the executor will directly jump to this method, which is show. Okay, now it will start executing this method. But when you are executing this method, there is a hold on demo, right? I mean, the main method is not continuing now. So main will continue for the next statement only when the previous statement is done executing. So once you complete the show method execution, then only it will go for the next show, right? And that's what it will do. So it will execute this show here. It will run this loop for 10 times and it will print hi 10 times. Now, once this show method is done with its work, it will go back to the main method and it will continue for the next method calling. So that everything basically goes in a sequence, right? Now, what I want to achieve here is I want to say, hey, you know, when obj1.show is getting executed, at the same time, parallelly, I want to execute this show as well. Okay, so if you want to execute two things at the same time or two behavior at the same time, since methods are behaviors, we can use something called threads. Okay, so we can say, okay, I want to execute these two objects, but then they are not normal objects. You can't execute normal objects in multiple threads, or you can't execute normal object execution simultaneously. So you have to use multiple threads here. So how do you make your normal objects as threads? Now that's tricky, right? It's actually very simple. If you want to make these classes or these objects as threads, just extend with a class called thread. It's that simple. The moment you extend with threads or with a thread class, now this class is not an ordinary class. This is a thread. Okay. The same thing you can do for B. So you can say thread and extends thread. Okay. And then you can come back here and our job is done, right? Now we don't have normal classes. We have threads. Oh, is it so simple? Okay, let's see. Compile and run. Oh, it's not that simple. You can see they are still running in sequence. They are not running in parallel. What I want to do is I want these two methods to run parallel. So while it is printing hi, it should also print hello on the side by side. Okay, it's not working. So what I am imagining with my code is what should happen is, see, there is a main method, right? So main will continue its work here. So main will keep executing everything. Now there will be a point where main wants to execute the show method, but with two different threads. So I want a show method here and I want a show method here. Of course, this show method, the first one is of A, the second one is of B, but then your main, when calls show, it should be with the new thread. So I want this to be a new thread. I want this to be a new thread. Okay. Now, just by mentioning that this class is thread, it will not create new thread for you. Basically, we want two threads. Now, the way you do that is by not calling show. What you have to do is you have to call a method called start. Because when you are thinking that at this point, I want to start a new thread. We want to start a new thread here. We want to start a new thread here. We can do that with the help of a start method. So we have to call this method. And that's what we are doing here. So you have to say start for both the threads. Okay. See, we are saying that those are the obj1, obj2, but they are threads now. Now the only thing is, when you call start, it should also say start, right? Why it is show? Now the thing is, behind the scene, when you go to start, so you can see if I go to start, start is a method belongs to a thread class. So of course you can do your work here, but the thing is it will create new thread for you, but it will call not the start method. Even if you call it, it calls a run method. So this thing you have to remember, in every thread, you need to have a run method. That's how it works. So when you say start here, it's almost like, when you are, when you want to participate in a race, right? So we have multiple lanes there, right? So we have multiple lanes, multiple people are waiting to start their game here. And of course you took a position to run, but then you will not run. You will wait for it, right? What you will wait for? You will wait for some volunteer here to say start, right? The moment they shoot a gun or they say start, you go, right? In the same way, the moment you say start here, it will execute the run method. Okay, that's the point you have to remember. Okay, let's see if this works now. We have done everything what we could have done to make it work, and let's see it works. Oh, okay. Still not working. Now what is happening here? See, the thing is, what if I say they are actually running parallel? The only thing is, when we are saying that, see, we are starting with this one, right? obj1. And then we are assuming that obj1 will execute one high, and parallelly, the second thread, which is the B thread, will execute hello at the same time. But the moment you give some time, because the machine is so fast now, the moment I have given some time to the A thread to execute, it is executing the entire thing at the same time. Okay, let me show you what I'm saying. What if I do this for 100? Okay. And let's see what changes. So if I compile this code and run, if you can see, if I scroll up, things are happening in parallel. Okay, so you can see we got few highs here, and then we got few hellos, and then we got few highs, we got few hellos. Okay, things are running in parallel. So these two methods are actually running at the same time. Yeah, so what happens is behind the scene, there's a concept of scheduler. Okay, so in your OS, we have a concept of scheduler. Now scheduler will say, okay, if you want to execute something, you have to come to me first. Now, it doesn't matter how many threads you have in your system. Of course, in my machine, I have shown you that in the last video. If you go to activity monitor, you can see we have so many threads here. We have 524 threads running, and only for one task. In total, I got 2,382 threads. Now, of course, you can't execute all at the same time, right? Now, the thing is, nowadays we have multi-core CPUs. So you have multiple cores there, right? And the beauty is you can execute multiple threads at the same time. So you can execute, let's say if I have 4 cores, I can execute 4 threads at the same time. If I have 8 core CPU, which is octa-core, I can execute 8 threads. But we have 2,394 threads now. How will you execute all? So of course you can't execute all at the same time, right? So they go for a time sharing. So scheduler in between. So let's say this is your OS here. Okay, so there's a concept of scheduler which is responsible to basically allow a thread to execute. Let's say we have multiple threads waiting to execute, okay? So let's say we have 8 threads here and then we only have 2 cores available. So on your CPU, basically, you have only 2 cores, right? So scheduler knows you can actually run only 2 threads at the same time. So what it does is it basically allows, let's say, this thread and this thread to execute. And then after they execute, they will allow this thread and this thread to execute, right? So it is scheduler job to allow which thread to go to execute on the OS, okay? And that's why, so when your scheduler allows some time for your threads to execute, your thread might be executing this number of iteration at the same time, okay? And that's what is happening here. So basically we are running multiple threads at the same time. So yeah, that's how you create multiple threads with the help of the thread class. And in the next video, let's try to optimize this more. And we can see how can we have one hi and one hello output.